All right. Now we're going to get back to value tables again, but we're going to talk about value tables. The first time in lesson 3, we just talked about the not operator. So now we're going to talk about the other operators, and that'll help us see how value tables can determine and evaluate the value of multi-letter woofs, right, or larger woofs. So we're going to talk about the AND operator. We're going to talk about the OR operator. We're going to talk about the implication operator and, of course, the equals operator. And maybe we'll do a little quick review of the not operator. Okay, so let's go ahead and get started with the AND operator. And actually, let's go ahead and review. So we'll put the not operator up here, its value table, like we did last time, just so we can see a little example. And we'll try and see if we can fit all of them on this one screen, so you can see how they develop over time. So remember, we're going to evaluate the values that this woof right here, P, can hold, and it can hold 2, right, plus and minus, and then not P is going to be if P is positive or plus, right, then not P is going to be negative. If P is negative, then not P is going to be positive. Okay, so that is our not operator. Now, for an AND operator, we have to do AND something, right? So we can't just do P AND. That wouldn't be a proper woof. In fact, let's go ahead and grab ourselves a different little color. And it's going to be green. So let's talk about, we've got 2 pieces here. We're going to have P, R, right? And then, of course, we're going to have to do P and R if we're going to do AND. So P and R. Okay? Draw our line. Suddenly, it is a value table. Great. Looking at this right now, I don't know that we're going to fit them all on here, but we'll get through as much as we can and see how many we can fit on the screen. So we're going to start off, and we're going to say P can be positive and R can be positive, right? P can be positive and R could be negative. P could be negative and R could be positive, and they both could be negative. Okay, so here's our index. So let's evaluate it. What happens when we say AND? Well, what happens is it starts to look like a little rule. And indeed, all of these value tables for these separate operators, we call them axioms because they're just always true. So we look at it and we think, you know what? If the AND operator makes the woof positive, then it can only do that when both of them are positive, right? We can't say it's positive and negative. No, it can't be positive and negative. It has to be positive, positive if it's going to be positive, right? So this would be positive. So here we have this split. So that can't be positive, right? So it can't be positive if one of them is negative. So we said that's negative. It also, this can't be positive. We're evaluating if the woof is positive. Put a little positive up here to make sure we remember. It can only be positive if both are positive, right? Because this one got a negative over here, so that's negative. And for sure, it can't be positive if everything is negative. So here's our value table, and we say, okay, so the AND operator makes the woof positive if and only if both parts are positive. So let's jump on over. Let's get let's make yellow here. So now we're going to do the OR operator. So let's do S and T. Okay, and then we'll evaluate the woof S or T. Let me put our line under here. Now we've got our value table. So once again, we go through and we make an index. We index all the possibilities here. S could be positive and T could be positive, right? S could be positive and T could be negative. S could be negative, T could be positive, or they could both be negative. Okay, so in this case, the axiom for OR, when is the woof positive? Well, it's positive. Well, actually, we talk about the OR operator in just the reverse of the AND. So the OR operator makes the woof negative if and only if both parts are negative. So here we have one positive. So can't be negative, right? In fact, let's make a correction here. Put our little negative over here, since that's how we're anchoring our understanding here. It can't be negative here because there's a positive that gets in the way. It could be positive or negative, but it could still be positive, right? It could be negative or positive, but it could still be positive. If it's negative or it's negative, well, then for sure it's negative. Great. So now we have our OR operator. I think we got enough room down here for a couple more. So let's move on to our implication operator. Let's see, what's implication? We'll do this kind of nice pink color. Okay, magenta. All right, this is magenta. Here we go. So for our implication operator, the implication operator, remember I told you it's like a magnet. It kind of holds on to things. So the implication operator makes the woof negative if and only if the first part is positive and the second part is negative. Now, I don't know if you guys remember or if you've ever played with a magnet, right? But a magnet, here's our magenta magnet, always has one side that is positive and one side that is negative. And they stick in opposites, right? So if we had a negative and a positive magnet over here, okay, then those would stick, right? If we switch the poles around, right, and we tried to stick the positive to the positive and the negative to the negative, right, it would push apart. And you've probably played with a magnet and felt that. So here's our implication operator. So let's do Q and M, okay? Or we'll say if Q, and this is how we talk about the implication, then M. Okay, that's how we talk about implication. So put our bar under here, and we say, again, we go through the values. It could be positive and positive. Q could be positive, M could be negative. Q could be negative, M could be positive, or they could both be negative. Okay, so it can only be negative if and only if the first part is positive. The first part of the index here is positive. So these can only be negative up here. These are the only ones that have even a chance. And the second part is negative. Okay? So that's how it can be negative. So this is going to be positive. First part is positive, second part is negative. That can be negative. Okay? First part is negative, second part is positive. Nope, that can't be negative. First part is negative, second part is negative, so that can't be negative. And lastly, let's go ahead and we'll grab kind of this cantaloupe color. All right. And we'll do our equals operator. So now we'll do X and Y. Ooh, you know what? Let's get a different color. Cantaloupe looks too much like yellow. Okay. So here we go. Let's, oops. We'll grab this, get a nice, maybe we can get this tangerine. That's kind of orange. That should be good. All right, so X and Y. X equals Y. Okay, so equals says that it has to be equal. So it can only be positive if and only if both parts are positive. So this was super simple, right? Positive, positive. It could be X is positive, Y is negative. X is negative, Y is positive. Or X and Y are both negative. So in this case, it can be positive if and only if both parts have the same value, right? That's how they're equal. So this one's going to be positive because they have the same value. These are equal. Nope, they're not equal, right? Plus and minus aren't equal, so that's negative. These, again, aren't equal. But negative and negative, those are the same. Those are equal, so that's positive. So there you go. Those are our value tables for all of our operators. We got them to fit on all on one screen. And you can get the exercise there on that PDF and see how you do.